here's our example for exponential decay models. We buy a new car for $22,500. The value of the car decreases 25% each year. So if we are decreasing by a fixed percentage each year, it's an exponential decay model, and we use this equation up there. And the last one we saw had plus because it was a growth. Now we see a subtraction in there, the minus, because it is a decrease. So write an exponential decay model giving the car's value V in dollars after t years. So we have to figure out our A value, which is the initial amount or initial value of the car. That's the 22,500. What else? We have our rate as a decimal. So 25%, we go over 2 spots, that's just a 0.25. And then t, they want to know what it is in t years, so we're actually going to keep that. They did throw out this value of v, so that's just saying, instead of saying y equals, we're going to say v equals the value of the car is equal to 22,000, and I'm just plugging in for the variables right now, 22,500 times 1 minus 0.25 raised to the t power. So here's our answer. Again, we just want to clean it up a little bit. We can figure out what this 1 minus 0.25 is. So in the end, v is equal to 22,500 times 0.75 raised to the t power. So there is the model. That's an equation that we can use to figure out the value of the car at any point. So the follow-up question is, what is the value of the car after 6 years? So we buy the car, we've had it for 6 years, what's it worth now? So 6 years tells us the t value. T is going to equal 6. So we just plug that in for the t. 22,500 times 0.25 raised to the 6th power. Now in simplifying this, we want to go ahead and do the exponent first, that 0.25 to the 6th power. So with the calculator, 0.25 raised to the 6th power. And we get, you may get problems like this on your calculator. With this scientific calculator, at least it gives us that E. What that E is that's scientific notation. So E with the -4 tells me to move that decimal place over 4 spots. So we really would have 0.000 and then the 244140625. So we come back here to the problem, and it's 22,500 times 0.00244140625. And again, the more, maybe I just said this, I don't know. The more decimals we use, the more accurate our answer will be. So we're going to take that decimal, multiply it by the 22,500 to get the value of the car after 6 years. Well, apparently it's not worth very much. 5.49, $5.49? So that's where, if we went from 22,500 and now we're to $5.49, it just doesn't seem right. So that's where we want to go back and just look at what we did. Let me try the, oops, 22,500, shouldn't matter, times 0.000. 244140625. See if we get the same thing. Yup. So I'm thinking there's probably a mistake here, but I'm not finding it. So here is the problem. If you think that the value of the car shouldn't be $5.49, since I've already recorded 5 minutes of this, I'm not going to redo the problem. So I'm thinking maybe a simple mistake was made. Maybe this is right. It just seems odd. So if you find the mistake, come and let me know. Maybe it'll be worth something to you. So good luck, because I'm going to try to figure it out too.